In this video, I'm going to look at some classic old meters. Now here I have two old volt-ohm-meters, VOMs. This is a Triplett model 630 and this is a Simpson 260. And these were standard meters that have been used for many decades. I think these go back to the 1930s, at least the Triplett I believe. And there were different models of these. But this video isn't going to be about the VOMs. It's going to be about VTVMs. Triplett also made a model 650 vacuum tube voltmeter, and Simpson made a model 303, this is a 303-2 vacuum tube voltmeter. Same style cases, they look the same, but this one has a line cord and this one has an outlet to connect 120 VAC input. So we're going to look at these two meters. I didn't know they had made vacuum tube voltmeters. I picked these up at a Hamfest in a box of old meters, and I was surprised to get home. I picked up the Simpson and I thought, wow, this has a line cord on it. I wonder if someone had modified this maybe for a battery supply. And then I looked at the Triplett and it had the outlet on the side, and I thought, well, that looks different. So anyway, I brought these home and we'll look at those two meters today. So I hope you enjoy this video. Stand by. I'm going to first look at the operation of the Simpson model 303-2 VTVM. Here's a schematic diagram of it here. And the way all of these old VTVMs work pretty much the same. You had a dual triode here, and what they would do is they would use it in a bridge configuration. And when the bridge is balanced, both of these cathodes would be at the same potential. And then the meter here is connected across the two cathodes. So when it's balanced, the meter reads 0. When they get out of balance, in other words, when you add an input, the unbalance will be measured across the meter. In this case, it's a 200 microamp meter. So if you look at here, these typically had a 1 meg resistor when you're measuring DC voltages here. A 1 meg resistor in series with a probe. And looking here, this string of resistors here are 17, 18, 19, 20, 21, and 22. These are the multipliers for the DC ranges here. And when you're measuring DC voltage on the selector switch on the front here, for instance, if you're measuring a negative voltage, the voltage would come up through the probe, and then through this connector switch here, it would connect the probe through R23 to the top of this multiplier chain here. And then the other side would be connected here. In other words, this, you see the arrow, this would be connected to negative or plus DC. That would connect it to the grid of the tube. So with no voltage in, you would balance the bridge, which would be equal voltages, and then by applying an external DC voltage, you unbalance the bridge, which causes the plate current on the left side to vary, and that would unbalance the difference between the voltage on the two cathodes, and of course that would be measured on the meter. And on this particular meter, you've got a switch where you can measure either negative or positive voltages. To change the polarity of the input voltage you're measuring, that was done in this switch here. And you see the cross-connected lines here. That would just connect the meter either plus to minus or minus to plus, and then that voltage would be fed through this lead to the right-hand cathode and through this calibration resistor to the left-hand cathode, so that when there's an imbalance here, which is caused by your input voltage here, that would measure on the meter. To measure AC, it's done a little differently here. You've got a voltage multipliers here for AC, which would be R13, 14, 15, and 16. And they're connected up to a dual diode tube here, 6AL5. Can't believe they did this stuff, but that's all they had back then, is vacuum tubes. Good for heating your house in the winter, I guess. But anyway, in that position you would short out the 1 meg resistor, and then looking up at the range switch up here, or the function switch I should say, the input would be connected through here to the AC multiplier chain here, and then to the plates of the tubes here, and then the other side the cathodes go to ground. And of course for resistance you had a 1.5 volt battery, in this case a D cell, and then that would be applied depending on which range is set through these resistors here, and that would be in the ohms position here. And this would be for the Simpson model 303-2. Here's a schematic diagram of the Triplett model 650 VTVM. Pretty much similar to the Simpson, although there's some differences here. The layout of the schematic's a lot different. If you look over here, you got your multipliers for your voltmeter, your ohmmeter, and your AC. Interestingly here, the Simpson, and like I say, there were many of these units made over the years. This older one here actually uses a dual diode. It's in a standard half-wave rectifier, but they've got the two tubes in parallel here. See the two plates across here? It's interesting. And in this case they used a dual diode in the probe to measure AC, and I figure they probably did that so they can measure higher frequencies. You know, having this at the end of the probe made it a little easier to measure higher frequency, I imagine. But if you look at here, it's the same configuration. You've got a bridge that's balanced, and then you got the meter that's measuring across the two cathodes. Here's the meter, here's your reversing switch, your polarity switch for measuring positive or negative voltages, and then you've got calibration pots here. Kind of like this layout a little nicer to read. So anyway, I'm not sure what years these were made. Like I say, this is a 650. There were newer versions of these. Here's the front of the Triplett model 650 here, or at least this variant of it. If you look on the front, you've got your range switches here, you've got your zero adjust here, you got your ohms adjust on the right, on and off switch, and a polarity switch to change the polarity of the probe on the right. Now looking at all the good stuff here in the back here. Here you've got your diode rectifier for the power supply, and this is old enough they didn't use a regular solid state diode. They actually use a tube, a dual diode here. This is a 12AU7. This is a dual triode that's used in the bridge circuit here, and around the circumference of this you've got all of your multiplier resistors. It's kind of neat how they're put together here. Your calibration pots you can see down through here. You can't smell this, but boy, when I took the case off of this, the smell of old electronics, and anybody that's into this hobby knows what I'm talking about. It has this special smell about it. It's kind of neat. Some people would find it offensive. I find it like a perfume like any other. Anyway, that's the inside of the Triplett 650 vacuum tube voltmeter. I don't have the AC probe for this one, so I won't be using this one on AC, but that's alright. These are more just for collector pieces. It's in fairly good shape though, a little wear and tear, but you know, after all these years you're bound to find a little of that. So anyway, that's the internals of the Triplett. Here's the Simpson 303-2 VTVM. This is a little newer version. 303-2. If you look on the front, similar controls. You've got your ranges, you've got your function switch, which measures, if you want to measure plus or minus DC, AC, or ohms. Ohms adjust on the right, zero adjust on the left. And looking at the innards, a lot simpler. I imagine this one was a lot cheaper to build than the Triplett. Looking at it, this one uses a semiconductor diode in the power supply here, and you've got your dual diode for your AC ranges. And here's a Telefunken 12AU7. This is a dual triode that's used for the bridge circuit. I haven't powered any of these on, so it looks like there's been some work done on here. Some components that have been changed possibly. I don't know the history of these. These units were all bought at a Hamfest, and normally if you buy something at a Hamfest, there's been a lot of hands in it. Hams with hands in it anyway. But like the other one, this too had signs of corrosion. Batteries always corrode in these things. I never put the batteries in any of these old meters because you forget about them and then they leak. I've got a couple. I think I got a 260. I leave a battery in, but I put a tag on the back with the battery date so that I can check them once in a while. Anyway, that is the innards of the Simpson 303-2. Blast from the past. Well, anyway, there's just a brief look at some old classics, old VTVMs from the past. Like I've said before, I don't have much use for vacuum tubes except for high power transmitters. Modern solid state devices are way superior and a lot more energy efficient, etc. But these are kind of fun to play with. And if you find one at a Hamfest, you might want to check it out. It's probably got a leaking battery in it, and sometimes if the batteries have leaked really bad, they can really do a lot of damage, so you might want to keep that in mind. Anyway, I hope you enjoyed this look at some old classics, and I don't have a whole lot of them, but I got a few. We'll cover some of them maybe in some future videos. So hope you enjoyed it. Thanks for watching, and see you in the next one. Bye for now.